For the laboratory from this semester, we used a ballistic kit. This kit contained a table with different angles from 10 degrees to 90 degrees. These angles simulate how bullets penetrate on the surface where they impacted. Inside the kit, there were also wooden sticks that were used to introduce into the holes, protectors to make sure that the angle of the hole was right, a string, and a cardboard measurement chart with instructions on how to use the kit. The teacher gave us a capillary to get the better measures of the and a decameter to measure longer distances. What we did first was to use the wooden sticks and stuck them into the holes. Then we used the protector to measure all the angles that the holes actually had. Then, calculating using height given it was 2.70 meters, the calculations were done from the average shoulder height from a man, 1.43 meters. The formulas used on this laboratory were trigonometry SOHCAHTOA, where we used the wall that created a right angle against the floor. And then we were given an angle and the height of the wall. This let us calculate the distance between the wall and the point that the man fired the bullet. Then we move on to sticking the table into the wall at the height given and use a string to the wooden stick. From then we tested most of the angles on the table, uh, tensing the string against the floor till it matched with the stick on the table. Then we used the decameter to measure the distance from the wall to the 10 string point, and from there we used a real person with the same shoulder height to actually measure where he fired the bullet from the point of his feet.
For the results of this experiment of the shooter shooting to a height of 3 meters, then was changed to 2.70 meters because the height of the classroom weren't enough for 3 meters. We had pretty much straightforward data that was uh, kind of the same as we expected for the first triangles. Mm, the first three smaller angles that we had in the table were pretty relatable to the results we had. It was pretty straightforward, and the calculus we made were good, and everything was as expected. But when the angles started to get wider and wider, there was 60 centimeters of error march from the distance of the shooter. This was because we couldn't really estimate where the shooter was, but we had an estimation from where he was. And this could be because of the position he was shooting and his arm um, extended of the bullet. This could have been resolved with another equation we later saw on class, but from the results we got, it was pretty forward, and we had 60 centimeters of error in almost every result, from the fifth one to the ninth one. But we got all the calculus right, and we found where the shooter was. And for the last 7, 8, and ninth angle that were like the wider angles, we didn't have room for the measurement to do the complete triangle in the classroom because they were really big. So we estimated with calculus, and we made our estimations of where the shooter should have been, and we got great results. We got all the same as the other angles with 60 centimeters of error, but it was a really successful laboratory. I think we got the expected data, we found out where the shooter was, and we found out how to basically identify where a shooter stands with basic trigonometry. I think something important to say about this experiment is that calculus and group work is really important and really necessary for this to work, because most of the time if one member of the group got distracted, we just screwed up the whole measurement and the whole data. So our results were good, work was good, and I think everyone had fun. That's the most important to me, because this simple math could have been taught through a board and in a boring class, but this experiment was really fun, and I think everyone did have fun and wants to practice it more. So I think it was a really successful project.